In this section, we draw on past knowledge of solving linear systems and apply the things we've previously learned to solving quadratic systems. So if you recall from Chapter 3, when we were solving linear systems of equations, we would use two different strategies, substitution and combination, either of which can be used here. And what you want to try to drive toward is what's going to be the simplest thing that you can use in order to solve your system. So in this case, we've got a pretty simple system. We've got a circle, x squared plus y squared equals 18, and we have a line, x minus y is equal to 0. So if I approach this from a substitution standpoint, I can solve the second equation here for x would be equal to y. I can then take y, I can substitute it into the other equation in place of x. So y squared plus y squared is equal to 18. That would be 2y squared is equal to 18. So y squared will be equal to 9, and y will be equal to plus or minus 3 when I take the square root. So what's different now from linear systems is that I have found two different solutions for y, and I need to plug them both back into the original equation. So I have x minus 3 is equal to 0, and also x minus negative 3, so that would be x plus 3 is equal to 0. So in this case, when y was 3, x is 3, and when y was negative 3, x is negative 3. So these are my two solutions. In a linear system, we would find one solution. In this case, there are a wide variety of different possible outcomes. In this case, two solutions. Again, remember, what we were talking about was the intersection of a circle and a line. So if I were to graph my circle, I have a radius here of 18. X squared plus y squared is equal to 18. So r squared is equal to 18. R would be equal to the square root of 18, which would be 3 root 2. Now we know this is just a little more than 4, right? The square root of 16 would be 4. 3 root 3 is just going to be a little over 4, so 1, 2, 3, 4 and a little bit. 1, 2, 3, 4 and a little bit, just to sort of give a quick sketch. 1, 2, 3, 4 and a little, 1, 2, 3, 4 and a little. And this would be my circle. Now when you think about a line intersecting a circle, right, there are basically three sorts of possibilities that could happen. The line could be, let's go ahead and put a line in here. So if I have a line and it's intersecting a circle, it could be tangent to the circle, intersecting at one point. It could pass through the circle, which would be intersecting in 2 points, or it could not hit the circle at all, which would be no solution. Now if we go back and we plot the solutions that we got 1, 2, 3, 1, 2, 3, there was a point there, and 1, 2, 3, 1, 2, 3, a point there. These were the points that my circle and my line shared in common. So I drew my circle poorly, otherwise it would have hit in that location. Okay, so one thing that's helpful to think about is if you know the different objects, then you have a better sense of how they might create solutions. Right, so in this case, my first equation is a parabola, and I know that because y is squared but x is not. This equation is a line, right? X and y are both to the first power. So when you think about a parabola and a line intersecting, they could intersect in a couple of points. They could intersect in 1 point. They could not intersect at all. Okay? If I want to do substitution, looks pretty simple here. If x is equal to negative 8y, then I can take negative 8y and I can plug it into the other equation. negative 8y plus 2y squared is equal to negative 6. Now this is going to be a quadratic function. If I set it to be equal to 0 and I go through the process of solving, 2y squared minus 8y plus 6. I added 6 to either side and then I put my terms in the correct order. I notice that these are all even numbers, so I can factor a 2 out of them. Y squared minus 4y plus 3. I know that my binomials will both have the same sign and that they'll both be minuses, so I'll have y minus and y minus. And I want factors of 3 that will add up to be 4, 3 and 1. So again, I got two solutions. Y could be equal to 3 and also equal to 1. And if I take these values and I plug them back up into my other equation, so I know, oops, excuse me, those are y values, not x values. Y could be 3, and y could also be 1. When I plug them into 8 is equal to negative 8y, I'll be able to find those. So x would be equal to negative 8 times 3 when y is 3, so that would be negative 24. Negative 24. And x would be equal to negative 8 times 1 when y was equal to 1, so that would just be negative 8. Negative 8. And here are my solutions. Make sure to keep close track when you're plugging the different values of y in to make sure that your y values and your x values end up paired in the correct ordered pair. Okay, if we wanted to review graphing this situation, I would want to put this into the proper form for my parabola. So I know that 2y squared equals negative x minus 6, and I would want to divide by 2. 2y squared would be equal to negative 1/2 times x plus 6. And so I factored a negative 1 out, I divided by 2. Now I'm in standard form for a parabola. I know that my vertex is at negative 6, right? H is negative 6, and k is equal to 0, so negative 6, 1, 2, 3, 4, 5, 6. I know that y is squared, so this one is going to open horizontally. It's going to open this direction, as a matter of fact. When I find p, I know that 4p is equal to negative 1/2. So negative 1/2, and p will be equal to negative 1/8 if I divide by 4. So I would move negative 1/8 in this direction to find my focus. I know my graph is going to wrap around this direction. When I graph this line, I'm going to want to put it into standard form. So I'll have 8y is equal to negative x. So y will be equal to negative 1/8 x. I have a y-intercept of 0, so I'm going to put a point in here, and I'm going to go, I would normally go down 1 and right 8, but you see that's in the opposite direction of what I'm trying to graph towards, so I'm going to go up 1 and left 8. 1, 2, 3, 4, 5, 6, 7, 8. Very, very flat, but when you think about what's going to happen with this, so this graph this line is going to continue to rise, while at the same time the parabola is going to continue to bend back over this direction, right, as it wraps around the focus. So eventually, in fact, we know where it's going to happen. It's going to happen all the way out at negative 24. We will impact and cross this again. So This gives you a sense of about what happens when you're looking at graphing. We don't have to graph these. I won't be requiring you to graph them, but I think it's helpful to understand what the graphs look like, so that you have a sense of, oh, what are the possible outcomes that I could have. Anyway, that's 10.7. It won't be pushed too hard on the tests, and what you want to draw on is the things you learned back in Chapter 3 for linear systems and how they apply to quadratic systems.